So in this paper, I'm going to be explaining event extraction, but we use the idea of zero-shot learning. So I'm going to be explaining this paper in 2022. Event extraction is a task of identifying interested event mentions from text. Conventional efforts mainly focus on the supervised setting. However, these supervised models cannot generalize to event types out of the predefined ontology. To fill this gap, many efforts have been devoted to zero-shot. So we try to link definitions to mentions, just leveraging the definitions. This paper follows the trend of modeling event type semantics, but moves one step further. We argue that using the static embedding of event type name might not be enough because a single word. You have seen in one of my videos that we just use single word, but it's very ambiguous. So in this paper, we want to use a definition, which is a long sentence or paragraph. And we need a sentence to define the type semantics accurately. To model the definition semantics, we use two separate transformer models to project the contextualized event mentions and corresponding definitions into the same embedding space, and then minimize their embedding distance via contrastive learning. I have a playlist for contrastive learning. So on top of that, we also propose a warming phase to help the model learn the minor difference between similar definitions. We name our approach zero-shot event extraction with definition. So this is an example of zero-shot event extraction task. You see, given a corpus, the goal is to identify all event mentions that fit the target event definitions without using any annotation. For example, for event catastrophe, this is the definition of that. So we are not using any annotation, but automatically we understand how they are related to each other. So this is the overall framework. In the offline training here, we train the model, we train the separate context and definition encoders with auto-extracted context definition alignment data. In the second warming phase, after knowing the target event types, as no annotation is provided, we first retrieve similar concepts from WordNet and use corresponding alignment data to polish the representation model. In the last inference phase, after encoding all candidate event type definitions, for each candidate event mentioned, we will encode it with the context encoder and determine whether it belongs to one of the target event types based on the cosine similarity. A simple cosine similarity we use for inference. So this is a definition. For example, get pleasure from. The mention could be, I love playing basketball. So we denote the context definition alignment as T, and here we follow the standard. The mean pooling of subtoken representation is this. And for sentence encoding, we just use the average representation of all tokens, and this is just feed-forward neural networks, and E sub k is a token representation of word WK, because there are different tokens. So then we use this marginal loss. Here epsilon refers to the margin, and this is maximum cosine similarity, and everything is obvious. We are just using this. We just want to minimize this marginal ranking loss. Similar to how human beings understand new concepts, while recalling relevant knowledge, we also retrieve relevant knowledge. So specifically assume that the set of interested event definitions is D sub hat. We first retrieve the most similar definition. This is the most similar definition from the original definition set. And for inference, we compute the representation for each candidate event mentioned in and target event type descriptions. After that, for each candidate, we compute its cosine similarity, as I said, with all the target event type representations. And finally, this is the zero-shot event detection with types plus supervision. You see, F1 score for identification is easy, but if you combine them, the classification and identification, so it is still below state of the art. And you see that with just 10% of training instances, you can get around 65 or 66 for F1 accuracy of both identification and classification. So we propose, given a set of interested event types, this model could automatically extract all event mentions that fit definitions from raw text.